Hi, welcome to 27 CSS channel. In this channel, we are going to publish videos related to CSS transaction server on ZOS. Let's talk about introduction to CSS in this video. What is CSS? CSS transaction server is often called as customer information control system, which is treated as the most powerful mixed language app server that runs on IBM mainframe operating system, which is called as ZOS. And CICS is widely used as an app server to host different apps for different companies in numerous industries like banking, transportation, government, travel, retail, and insurance. The languages supported by CSS are categorized like modern programming languages like Java and JavaScript, and traditional programming languages like assembler, COBOL, C, C++, PL1, and Rex. The beauty of CSS is as it supports multiple languages. So a programmer has a wide variety of choosing the languages which best fit for his application. And coming to the pronunciations of CSS, like in few parts of the world, they pronounce it as CSS, few they call it as CICS. So it depends based on the region you call it differently. Okay, and before we talk about CSS, I think it's good to know what is the difference between batch and online. What was the need for people to create online when they have batch? Okay, so let's go back to 1970s. Like in those days, like transactions were run in only batch mode. But running transactions in batch mode, there are some concerns expressed by the users during that time, like the turnaround times were lengthy and they are not at all acceptable, and the users were demanding for an up-to-date information because the time batch runs is too lengthy, so the results they get might be outdated, and users were looking for quick response time. So that led to the online processing, transaction processing methodology. So these are the prime differences between batch and an online. If you see, the batch is scheduled to run at a specific time, whereas an online, it can be initiated at any time when services are required. Whereas in batch, input is passed as a bunch of requests. When you compare with online, input is provided by the user in an interactive way. In a batch, it's delayed, output is delayed, and whereas in online, you get an immediate output. Again, when you compare batch, whatever resources it tries to control, including files, it has exclusive hold on that, and whereas online, the resources are shared, and if you compare with files, it can be at a record level as well. So yeah, this slide talks about the concerns which a developer community has. So when you design and develop, an application developer might have some concerns on these areas, like he can have concerns related to security or integrity of data, or how he can handle the exchange of incompatible formats of data between apps. So to address all these concerns, CSS itself has some built-in services, so which can address these concerns, and the developer can focus on his business code instead of worrying about these factors. So like the services provided by CSS are like it provides the security, whereas having said that, the application developer doesn't have to worry about the security of his apps. It is all controlled implicitly by CSS. Okay, and transferring execution and data between programs is important because as we discussed, CICS is a mixed language transaction server. Having said that, the need is like it has to exchange or call programs which are designed or developed in different languages, and they have to exchange data among them. So the, for that, CICS has developed an API which is tailored for each language, and using that API, the programs can call each other, and they can uh, share the data among themselves. And even though the API is tailored for each language, but the functional effect is same across all the languages. And CSS also ensures the integrity of data by using the commit and backward methodology implicitly, and even it provides explicit API commands like sync point and rollback. So with that, you can ensure the integrity of data. And another service provided by CSS is you access information present stored in a database and also in a mainframe dataset, and not just access them in case if there's any failure, there's any system failure while accessing these datasets. Even a backup can be initiated by CSS. And CSS also provides a service wherein your app program can interact with different resource managers like DB2, MQ, and IMS. And even it also provides a service like handling business events with the help of event processing. So an example could be like you can detect abnormalities in the customer behavior, and you can identify the frauds situations ahead. Okay, how do you define CACS? So all these definitions are true, and in most of the CSS books you see they refer CSS as an online transaction manager. Anything and everything in CSS runs as a transaction. And having said that, uh, many users can run a number of transactions. So that way CSS they refer it as an online transaction manager, and even CSS is also referred as a multitasking system, wherein multiple transactions can be triggered at any given point of time. And it is also referred to as a resource manager, wherein CSS handles resources on behalf of an application. So that is the reason they call it as a resource manager. And it is also referred to as a ZOS subsystem, wherein it provides services and functions by interacting with other ZOS subsystems as well, like VTAM, VSAM, DB2 IMS, and RACF as well. So these are the couple of definitions which you see in most of the books, and I treat CSS is a piece of storage. When you bring up CSS, what it does is like it get holds of the storage what you request it to, and once it acquires that storage, it loads the CSS code itself and the application code as well. Once the storage is acquired, it stays active as long as the CSS region is active. And another advantage of CSS is users can log in into the region and get hold, can run their programs in an interactive way. So when I say that they run the programs, those programs are run in the acquired storage uh, during the CSS initialization. Okay, this slide talks about the CSS history, though this starts at 1970, but CSS is way back developed in 68, and I think it has surpassed almost 50 plus years. And these are the major achievements they are trying to highlight here in the slide. These are the milestones which CSS has crossed in its life cycle. And this link provides the complete history of CICS. Okay, and these are the services, CICS services in detail provided to the application programs. So CICS provides file control, which is used to access vSAM and BDAM files, and it provides terminal control wherein it helps in interacting with terminals so that users can log into a CICS region using a terminal and they can interact with CICS. And there are at specific times a requirement wherein a transaction has to be triggered or some activity or function has to be taken care at a specific given point of time. So that is provided by the interval control. And coming to the task control, it takes care of all the tasks which run and the usage of resources in a controlled and synchronized way. And there's another service called storage protection and transaction isolation. In a nutshell, we can think it like storage protection is useful to protect the CSS code from apps, and transaction isolation protects the tasks from each other. So the storage is not violated and applications run smoothly. And we have two other data controls like transient and temporary storage. These refer to the TDQs and the TSQs. They are used to temporarily store data, whereas in TSQs, you can even store data in main storage as well, which you cannot do it in the TDQs. And you have something called as CSS also provides something called as documents and document templates, which is mostly used in web support. And apart from that, it provides other services like named counter servers and printing and spool files. And BMS is used for interaction with terminal users, especially. Yeah, these are the services which CSS provides for application programs. So having said that, the application developer doesn't have to worry about these services, because when you write your code and try to run in CSS, these services you get it inbuilt. Okay, you don't have to code it in your application code or worry about that. Your application developer can just focus on the business logic. Yeah, and how do you invoke an application inside CSS? So for that, you need something called as audio to make it work. Any resource you try to access within CSS, it has to be defined inside CSS by using audios. Audio stands for resource definition online, and here in this slide we are trying to show you like there's a program called hello C, okay, which is defined, and for invoking a program you need a transaction. So here we have defined a transaction called hi, which is tagged to the program hello C. Okay, so when a transaction is invoked, okay, what actually happens is a task is created. Okay, a task is a single instance of an execution of a transaction, whereas it has its own private set of data, so it doesn't uh, interact with other task data, or like each task has its own unique set of data. So that way CSS allows you to run multiple instances of same transaction, which is called as a task. Okay, and once you invoke a transaction, this is the flow of a transaction. Okay, so in this example he's trying to show like someone on a terminal user has triggered a transaction called ABCD, and then once a user triggers ABCD transaction in this example, the terminal control comes into the picture. and even some system services like checking if the user has access to run this ABCD transaction and loading the program from the program library is taken care. When I say loading the program from the program library, that is where the physical source is present. And uh, I mean, the physical program is present. So uh, the program from the program library, the program is loaded into this CSS storage. Okay, and then it starts running. So in this case, it has a map, so or a screen. So the basic mapping support has come into picture, and it has loaded or it has sent a screen to the user. Okay, and now the user has inputted some text, has provided some input, and uh, the earlier program ABCD00 has linked to this program, which is designed to accept the user's next input. And in the program logic, um, some details are requested from a file. So file control service comes into picture, and it opens and reads the file. And again, at the end, the terminal and BMS services read the data and format it according to the BMS screen and passes the data back to the user. So this is how the services in CSS are used, and the user can just focus on his business logic. He doesn't have to worry about all these services because they're implicitly taken care by CSS. Okay, uh, here we are talking about the compile and link edit of a program, the steps involved in compile and link edit of a program in a batch mode. Okay, if you want to run a program within a batch, like what all steps are required to compile and link edit, that is shown in this picture. So you write a source, you write a program in any source language, whatever you pick. In this program, A is written in COBOL and program B is written in assembler. So you use a COBOL compiler and compile the source, okay, which in turn generates an object code. And because this program is calling program B, which is written in assembler, so you need to have an assembler to assemble this program. And it generates an object code for program B. And there's another step called link edit where it links both these programs and creates a load module. So if you see, this load module has references to program A and B as well. Okay. So this is the executable module, which a user can execute. Because it's batch, you need to have mechanisms like a JCL to execute this executable load module. Okay, yeah. Here i- it's just a sample COBOL source program which is used in batch. So this just displays a message on the screen. So this is the source, and in the compile step, there is a COBOL compiler which is used to compile the source, and this is the link edit program. Okay, and once you compile and link edit, then you get a load module. So the load module is stored in a load library. So once you browse that, so this is the kind of view you get, and you can browse the content of the module. So and you can have some eye catchers of your display statements like this. So you have executable load module which is ready for execution, and this is how you invoke the program which you have created. I mean, compile and link it. The program name is hello. You just pass on the program name in the exec statement. Uh, and you also need to refer the location of this program that is in the step lab, um, where it is stored. So once you submit this JCL, then you can check the output in SDSF, and there's a sysout generated. That is what you mentioned here, to route the sysout to SDSF. So you check the sysout, then you get the output. Whatever you have mentioned in the display statement, you get that output. This is the way you run a program in a batch. Okay, and coming to like how things are run inside CICS. Okay, so let's see how compile link edit happens in CICS. Okay, first let's focus on the red colored box. This red colored box just talks about if you have a COBOL CICS program. Okay, then we will jump on to the green color box later. Yeah, you have a source written in COBOL, for example, and in that you have embedded the CICS API commands. Okay, so that is the way your COBOL program interacts with CICS using the execute CICS commands. That is the API commands provided by CICS. Okay, so once you have the source ready, so there is some, when you compare with the bash, there is some extra component which comes into the act. That is your CSS translator. Okay, so you pass the source to the CSS translator first. Okay, and the output is then um, submitted to the compile and or assemble program based on the language, if it's a COBOL or assembler, and then you do the link edit, and then finally you get the application load module. Okay, in case if your COBOL program is also having is also interacting with DB2, then an extra few extra steps come into picture ahead of your CSS translator, which comes into picture. That source should be subjected to something called as DB2 precompiler. What exactly it does is like just like we have CSS APIs, we even have DB2 APIs or SQL APIs like exec SQL and index SQL. So those statements, the exec SQL statements, are commented out, and they are placed in a different library called DBRM. Okay, so the rest, once you have commented out the SQL statement, the rest is again a normal CSS, COBOL CSS program. So these steps follow. Okay, and finally you end up getting a load module. Okay, but what happens to the SQL statements which are commented out is they sit in this DBRM library. Okay, um, so those SQL statements are subjected to a process called bind. Okay, bind is nothing but compiling your exec SQL statements, right? And it creates some executable um, thing called as a plan. Okay, uh, which resides inside DB2. So for a CSS DB2 module, for a COBOL CSS DB2 module to work together, so it requires two things. One is the application load module, and also the plan, which is sitting inside DB2. So how these two things gel together, that we will see in the upcoming videos. Okay, so for now, let's move on. So this green color part is showing the process which is related to COBOL CSS DB2, and the red color part is showing the process which is involved for COBOL CSS modules. Okay, let's move on. Yeah, this is the COBOL source code where you have embedded the exec CSS API. In this example, we are trying to send a text from the which is the text message is stored in this variable. You can see here in the working storage section. Okay, and this is the text we have moved into this variable, and that is being sent to the CSS terminal from where the user tries to run this program. Okay, so these are the CSS APIs which we are talking about. So once the source is ready, so that has to be subjected to the translator. And once it is translated, and this is the translated program, and once it is translated, these exec CSS statements, they get converted into the call statements. That is what you see in our program. We have two exec CSS statements, and each one of them are transferred or transformed into a call statement internally. Okay, so once that conversion happens, then that output is passed on to the COBOL compiler, and then passed on to the Linkedit program. And this is how your SDSF output of a compile Linkedit of a COBOL CSS program looks like. You have a translator step, you have a compile Linkedit step, and you can check the error messages, and once it's all clear, then a load module is generated. And if you browse the load module, you can see some eye catches whatever you're trying to send, like here in this case. Okay, so as I said, for programs to be invoked in CSS, you need a audio definition and a physical load module as well. So having assuming like the audios are ready and the transaction name is high. So the way you invoke a program in CSS is first you log into a CSS region where you have your load module placed, and once you sign on, then you trigger the transaction. So once you trigger the transaction called hi in this example, you get the output on the CSS screen. So this is how you invoke a program in CICS when compared to batch. So here you don't run a JCL, you just log into CICS and trigger a transaction. And the transaction flow which we have discussed in the earlier slides, that takes place, and you get the output on the screen. Okay, thanks for watching this video, and if you have any queries or training requirements, uh, please feel free to send an email to this email ID. Thank you.